Wave can be defined as a disturbance which can be transferred from one point to another without causing any permanent displacement of the medium. What do we mean by that? We have, for instance, a young man standing right here and another guy standing right on the other side, and this guy is holding a rope and he's flipping it towards the direction of this other guy B. You will observe that there will be some movement, a rhythmic movement that is passed on from the guy A to the other guy B. Now that movement causes a disturbance. In other words, causes kinetic energy that is being moved or propagated from here to here. In this case, we say this is wave. So we can say wave is a disturbance that can be transferred from one point to another without causing any permanent displacement of the medium. The medium is still going to remain how it is, but disturbance is moved from one point to another. Frequency. And what is frequency? We are going to be using a diagram to explain what frequency is. This is a sinusoidal wave, or we can call it a sine wave, where we have our x and y. Here represent the x direction and here represent the y direction. The frequency. Now let's talk about frequency. Frequency means the number of oscillation, number of complete oscillation in 1 second. Now look at one oscillation in my wave motion. From here to here is one complete oscillation. I repeat, from here to here is one complete oscillation. Let's count the next. From here to here, 2 complete oscillations. So the number of complete oscillation in 1 second talks about the frequency. And don't forget, frequency is measured in hertz. Wavelength, which is represented as lambda. Wavelength talks about the distance between 2 successive crests and 2 successive troughs. In our wave diagram, we need to understand what is the crest in this wave diagram and the trough. Now, the top part of our wave diagram represents the crest, and the lowest part attained by our wave particle or diagram talks about the trough. So here is the crest, and here is my trough. So the distance between 2 crests or the distance between 2 troughs talks about my wavelength, and wavelength is measured in meters. Knowing this, it is important for you to understand the equations formula that can be used to tackle questions related to wave. One of them is my velocity, which is given as my frequency multiplied by my lambda. Take note of this formula. The second one is my frequency, which is the inverse of my period. The next one is my period, which is the inverse of my frequency. Now let's talk about what period is. Now period talks about the time taken for one complete oscillation. Now this is one complete oscillation. Can you see that? One complete oscillation. Now, what is the time taken for one complete oscillation? That is called my period, and it is measured in seconds. So the equation, which is y equals to a sine, open brackets, wt minus the phase angle, close bracket, where my y represents displacement, usually the vertical displacement, and then my A represents the amplitude. Amplitude talks about the distance, the maximum distance attained by the wave motion. That is from here to here is the maximum distance. So this is my amplitude. Let's say, for instance, if it is 10 cm. So from here to here, if it's 10 cm, it talks about my what? My amplitude. Your W talks about your angular velocity. Angular velocity. And then your T represents your time. Y, this one represents the phase angle. Don't forget your A also represents your words amplitude. Now, remember, we'll go to the next part. Using this our equation, now we are going to derive so many equations that we can use to calculate wave motion. Now let's start. Remember, W, according to simple harmonic motion, is equal to 2 pi f. This W, which is the angular velocity, and it's represented as 2 pi f. Now, while your phase angle is 2 pi x over lambda. So this my phase angle is usually where I can find or locate my wavelength, which is my lambda. Now we are going to substitute all these things inside the wave equation. So we are going to have y equals to a sine, open my brackets. Now we have W, but remember we are going to substitute W to be 2 pi f. So we are going to write 2 pi f and t right here from the t. Then minus my phase angle, which is given as what? 2 pi x over lambda. So this is the first equation for wave that you need to memorize when dealing with questions or calculation involving wave. We can move on by writing what is f. Remember, v equals to f lambda. So therefore, my f will be equal to v over lambda. Now, I'm going to substitute f in this equation, but we are going to do something before we get that. Now, when you look at these two parts of the equation, you see we have a common factor, which is 2 pi, and here we also have a 2 pi, so we are going to factorize it. So we are going to have y equals to a sine. Then we bring out this 2 pi, we bring out one of it, and then we close it. Now we are going to be left with ft minus x over lambda. Can you see that? Can you see that? Now we are now going to change f to what it represents. F is equals to v over lambda. So what are we going to have? We're going to have y equals to a sine 2 pi, open your brackets, then f, we're going to substitute it with v over lambda, then multiplied by t minus x over lambda. Looking at this new equation, what is the new thing we have in common? We have lambda in common. So we're going to factorize it or bring it out again. So we're going to have y equals to a sine 2 pi. Then this comes out as the denominator. And then we have our vt minus x. And this is our equation for wave. Wave equation, which is y equal to 2 sine, open bracket, 2000 pi t minus 0.5 x. Now we are asked to find the frequency. How do we solve for this? Now, this part or this part, where do you think we can find our frequency? Our frequency can be found around here. So we use this to equate with our wave equation, which is y equals to a sine, open bracket, 2 pi ft minus 2 pi x over lambda. So this is where you can find your frequency. So we are going to use this to equate it with this one. So we are going to have, from the question given to us, we have 2000 pi t is equal to this equation, which is 2 pi ft. Can you see it? So what do we do? T cancels t, pi cancels pi, so we are left with just 2000 equal to 2f. Now we are looking for f divided by 2, so 2 cancels 2, and then my f becomes 2000 divided by 2, and therefore my f equals to what? 1000 hertz. So this is the frequency. I also want you now to do this as assignment. Use this same equation for wave and find the wavelength. Of course, the wavelength should be found around there. I want you guys to do this and submit it on our WhatsApp group or our YouTube channel. Please drop